Welcome to the Graphisoft Open Design Collaboration presentation. In this presentation, you'll discover how architects and engineers can exchange building design information, share and manage changes, and create professional, fully integrated construction documentation. Graphisoft ArchiCAD. Graphisoft was founded in 1982, over 25 years ago. ArchiCAD 1.0 already implemented the virtual building concept. Today, this is known as BIM, that is, Building Information Modeling. Virtual building, or BIM projects, are better designed, more predictable to construct, and less expensive to operate. During the last 25 years, over 1 million building projects worldwide have been designed and built using ArchiCAD. Graphisoft is represented worldwide, and ArchiCAD is distributed in 102 countries. It's available in 17 languages and 25 localized versions. ArchiCAD runs on both Microsoft Windows as well as Apple Macintosh operating systems. We put great effort into providing a high-end software solution for design professionals. ArchiCAD provides a fully integrated building information modeling, design evaluation, and documentation workflow. Designers using a true BIM, Building Information Modeling, software solution and workflow will need less time to complete an architectural project. The project will be more consistent than a project using 2D tools. The documentation and coordination issues become almost automatic procedures, and the overall time to market is shorter. Collaboration with engineers will be easier, smoother, and more productive. Throughout this presentation, we will focus on how designers can work together with engineers and present the design workflow between architects using Graphisoft ArchiCAD and structural engineers using Revit Structure. Open BIM concept. Structural applications have at least one of the following primary functions. Modeling. Modeling applications are used to create the engineering model based on the architectural reference model. This model serves as the basis for analytical and detailing applications. Analysis. Analytical applications are used for stress displacement calculations. The results will then be used as the basis for the steel, reinforced concrete, or timber design. Detailing. Detailing applications develop reinforcement drawings and steel detailing, and they usually connect to manufacturing applications such as CNC machines. Revit Structure is an engineering modeling application that creates physical, structural, and then analysis models from the architectural input, and also has links with analysis applications via the so-called add-in applications. The integrated workflow covers the following activities. Preparation of our own model based on the fact that we would like to share an intelligent model or data with others and other software users. Filtering only the necessary or required parts or elements of our project. Exporting the filtered or entire model to others depending on the requested workflow. And the opposite direction. Supporting the import of other disciplines into our software. There are different modes of data exchange. 3D model exchange. The so-called IFC or direct model links via add-ons and add-ins developed by others for ArchiCAD and Revit Structure. 2D drawings such as DWG, and finally, documentation such as PDF, the most popular one, which can be shared and integrated easily between applications. The export and import process is repeated in additional cycles, so tracking changes between architectural or structural model versions is also very important. The reference model concept is the most important workflow concept used throughout model export, import, and change management. Each discipline is responsible for the creation and development of its own model. Reference model means that a discipline, let's say the structural engineer, uses the architectural design model for the basis of creating the structural model. The structural model will be created as a standalone model, yet some initial design information will be taken from the architectural model. Version tracking or change management can be established very well for the reference model versions of the various disciplines throughout the design workflow. The different disciplines, such as the architectural and the structural, use different design concepts and tools to create their own model. Let's look at a quick example to demonstrate the major difference between the modeling concepts of two disciplines. The architect designs a two-story column as one continuous column element in the architectural design. The structural engineer will define two separate structural column members in such a case. Both analytical and detailing applications need to consider two separate columns as well. Slabs are also handled in different manners by the disciplines. Architects typically create one single slab that spans across an entire story. Structural engineers divide the single slab into units to comply with the various structural requirements and define, for example, hollow core concrete panels. IFC is an open, intelligent, object-oriented file format. It is used industry-wide as the common platform to exchange building information modeling data between AEC applications for the entire life cycle of the building. Let's review some of the IFC benefits. IFC supports the reference model concept. IFC provides 3D geometry representation for all project elements. IFC also stores standard and custom data about each element, such as materials, profiles, functions, and so on. The applications used by the disciplines can easily and quickly filter and identify the relevant discipline-specific information from the IFC database. IFC is an open standard available freely for all software vendors. IFC is used industry-wide as the common platform to exchange building information modeling data between AEC applications for the entire life cycle of the building. Graphisoft and Autodesk are members of the Building Smart Association. Both companies have already proven their commitment to open IFC-based BIM collaboration, and they both have the highest IFC certification level. Using IFC for the basis of BIM collaboration, in actuality, means that designers and engineers can collaborate safely and efficiently with other disciplines using other software. On this slide, you can see a collection of design, analytical, structural, mechanical, engineering, plumbing, and fabrication, as well as project and construction management applications that ArchiCAD and Revit Structure users can connect to via IFC or other exchange file formats. ArchiCAD Revit Structure Workflow. Before starting the applications, let us briefly overview the main steps of the Graphisoft ArchiCAD and Revit Structure building design workflow. 1. Let's start with the architectural model. Architects create the first model according to the client's request in the given site. 2. To prepare the model export, architects can filter the structural elements by using element classification, layers, layer combinations, display settings, selection modes, and so on. Of course, the entire building can be exported without any filtering as well. 3. Architects export the filtered model in IFC file format. Predefined, so-called translator settings optimized for the export to Revit Structure are recommended. 4. Engineers receive the architectural model and open it as a separate Revit Structure model. Of course, more filtering can be done for the imported entire model, if it is requested. 5. Engineers link the architectural model to their structural project as a reference. 6. Engineers define the structural model and its details based on the referenced architectural model. They can also generate analytical models for analysis applications. 7. The ready structural model, or a filtered part of it, can be exported back to the architects. Engineers also use IFC file format for the model exchange. 8. There are two possible ways architects can import an IFC file. They can merge the structural model into the current architectural project, or they can open it as a separate new model. Filtering is also available for the import, and imported elements can be placed on given layers. By default, the new imported elements are protected according to the reference model concept. Architects may compare two view sets. One contains the architectural model, and the other contains the imported structural model. They can use the Trace and Reference tool to aid the comparison of the floor plan and section views. Architects can query the profiles and materials decided on by the engineers. 9. Architects can modify their project according to the imported reference model, or they can accept imported elements by using them as real ArchiCAD type elements. 10. They can export an IFC file again based on the project's new status. 11. Structural engineers can update the previously linked architectural reference inside the running structural project. 12. Engineers can make changes in the project based on the changes of the referenced architectural model. 13. And engineers send the new structural model version back to the ArchiCAD user. 14. The new IFC file received in ArchiCAD can be compared with the previous structural version. The result of the comparison is listed before merging it into the current running architectural project. 15. The comparison process automatically merges the detected changes only, so the new, modified, and deleted elements will be inserted into the architect's running project as a reference. 16. The architect can easily check the changes recommended by the structural engineer, or can make modifications to update the design manually, or by using structural elements as real ArchiCAD elements. Both engineers and architects can repeat the previously mentioned model exchange, comparisons, and updates in additional cycles. Finally, the two disciplines make their own or combined documentations. Let's see the previously described workflow in practice. We will be using a 32,150 square meter residential building complex in our presentation.